Hi, how are you guys? So this is gonna be the second video to solve the palindrome number problem. In the first video, if you haven't seen it, I'm gonna put the link up here. In the first video, we changed the integer into a string and compared numbers. But in this video, we are gonna not change it to a string. We just gonna keep it as an integer and try to find whether a given number is palindrome or not. Okay guys, so now coming to interesting problem. If we cannot change it to string, what can we do? So the first idea that you may have is maybe turn that whole, reverse the whole integer. This one here, 2 and 1. But if your number is something like 999 and if you reverse it, it maybe get something like that, and this may be too big for your computer to handle. It is called int overflow, because it cannot, your computer has certain bits and it cannot represent this integer inside that limitation, so it overflows. And there is a better way. Let's say your number is 1221 1 2, let's say if your number is 1221, so you don't need to reverse the whole number. If you just reverse the half of it, let's say 1 gets here, 2 gets here, and compare this number with this, if they are similar, it's a palindrome number. So you can just reverse the half of the numbers. Okay, so let's see how we can do that. So our goal is, if this is our number, our goal is get 1, and to get the last digit out of any number, you just do module 10, and then let's say this is reverse number, so you will get 1. Just on a side note, if you do module 100, you get last 2 digits. Module 1000 gives you last 3 digits, and so on. So you can do module 10 on this original number and get 1, and then you divide this number by 10 and get 122. So your original number get reduced by 1 digit, and then you can do module 10 on the reduced number and get 2, right? Module 10, and you have to put this 2 here. So how you can do that is your times this 1, so that you can do 1 times 10 and add this one here. So now that's 12, and then you can do divide this by 10 again, get 1 2, right? And then you can see, okay, this is just 2 digit, this is also 2 digit, your reversed number. So you know that you have reversed half of the digits, because you started with 4 digits and now at 2 digits. So you already have half of the number reversed. Then you compare this 12 with this 12, and if they are same, then it's a palindrome. If the number is 0, it's a palindrome. If it's a negative number, then if you reverse it, it's not gonna be valid number, so it's not a palindrome. And any number, let's say 10 20 30, if you reverse it, it's a 0 1, so they are not same. So any number that ends with 0, it's not a palindrome number. Okay guys, I just want to mention one thing real quick, that if you have even digits, you can just compare, because this is going to be original at the end and this is going to be your reversed in reverse order, and you can just compare this. They are both 2 digits. But if you have odd digit number, let's say 1 to 1, what's going to happen, that you module this by 10, and then this is going to be reverse number, then you divide this by 10, this is going to become 2 12, and then you module this by 10, so that's 2, and you put it here, so your reversed is now 12, and this is gonna, you module this, divide that by 10, and this is gonna be 1. So your original is gonna be 1 and your reversed is gonna be 2, right? Because it's odd digits, so original or reverse, one of them gonna have 2 digits and other are gonna have 1 digit. So when you compare, you have to make sure that you compare this one with the outer with this one, right? If they are same, then it's a palindrome because the middle digit is always gonna be, it's not gonna match, right? So to compare this one, as you now know, you can just divide by 10 and that last digit goes. So you compare one with this one. So you will see in our algorithm, when we return, we say return whether original is equal to reversed or original is equal to reversed by 10 to account for these odd numbers, right? So if this is true, it's a palindrome, or this is true, it's a palindrome.
So let's say if x is 0, return true. So if x is less than 0, any negative number, or 10, 20, 30, anything divided by module 10 is 0 is false, and then we can do our thing. So we can int reversed, let's say rev is 0, and then while our original is called x, while x is greater than reversed, we are gonna do that because we are reducing x by one digit at a time and adding it to reverse. So let's see, rev is gonna become rev times 10 because we want to add it. So at first we are multiplying 0 with 10 and adding the last digit. So the last digit of x you get when you module by 10. Okay, and whatever number you get, let's say 1 or 2, then if you want to add another number to it, you divide this with 10 and add the next number. So that's how it's gonna keep adding at the end of the reversed number, and then you decrease the original number by 1. So that by divided by 10 is gonna reduce, delete that last digit as we talked. And then at the end we are gonna, once we are done putting half of the number in the reverse order, we are gonna compare return x equals where. So if this condition is true, we are gonna return true. Or so you can do x as we talked. Let's see if it works. All right. Okay, that's cool. Let's submit this. All right, we are good, guys. So that's it. See you in the next video. Thank you.